Hi, I'm Tim Berglund with Confluent, and I want to talk to you today about your journey through data warehouse modernization. We'll walk through an example of how to migrate your data from a legacy data warehouse to a cloud data warehouse using Confluent. To set the context, organizations today are being bombarded with a lot of data. Data that you're expected to filter, analyze, and otherwise use in order to drive business decisions, improved customer experiences, and automated back-end operations. Traditional data warehouses were just not built with today's digital-first, cloud-native requirements in mind. They are relatively slow and rigid and expensive in terms of both upfront and ongoing maintenance costs, and as a result can have a more limited set of analytical capabilities. The shift to cloud data warehouses brings with it a fundamental change, decoupling compute from storage, and this gives us benefits like reduced TCO from things like consumption-based pricing innovations and increased elasticity to support the demand that doesn't just grow all the time, but grows unpredictably and presents an increasing variety of kinds of workloads. Cloud data warehouses are also quite analytically capable, empowering the rest of the organization to self-serve data by supporting, of course, effortless concurrent access and newer things like machine learning and predictive analytics. However, the journey to a cloud data warehouse is often a long and complicated one, requiring multi-year efforts spanning multiple teams and tools. There are a few main challenges that you'll probably face with this kind of migration. First, it's time and resource intensive to load new data into the cloud data warehouse and manage data pipelines across on-prem, cloud, and multi-cloud environments. Second, a large portion of the data needs to be processed and cleaned, but it gets expensive when large-scale data processing occurs inside the cloud data warehouse itself. In some cases, an intermediary step might be needed, like using another database for pre-processing. And finally, companies struggle with integrating multiple data silos with a variety of data models and schemas all across the organization with what you might hope is a single unified schema in the cloud data warehouse. Modernizing your data warehouse doesn't need to be this long and arduous journey. With Confluent, you can start migrating immediately by linking across on-prem and cloud environments with real-time event streaming. Now, you'll usually generate more data than you need to analyze, but Confluent can help you reduce your cloud data warehouse spend by processing that data in flight with ksqlDB. Finally, our Data in Motion platform has a rich ecosystem of pre-built connectors to help you break data silos and connect your distributed data sources across the organization. Let's get on with an example where we'll bring this use case to life. Let's look at a pretend retailer. We'll call them Blue Mariposa. Let's look at how they'll go about their data warehouse modernization journey by migrating data from Oracle and Postgres to BigQuery. Let's say Blue Mariposa uses Oracle on-prem to store most of their business-critical stuff like customer data. However, they have online orders in a cloud instance of Postgres. Maybe another line of business owns the data stored in Postgres, or they haven't completely integrated an acquisition yet or something, but the point is that they've got some data silos across on-prem and cloud environments, which is common for a lot of organizations. That's preventing them from getting a more complete and holistic view of their customers so they can create real-time personalized promotions, which is a thing they want to do. The data science team at Blue Mariposa is eager to start analyzing this data and generating insights, but they face a couple of challenges. First, the data they need lives in two separate systems and environments, like I said, Oracle and Postgres, and they'll need to access and merge that data in order to get a unified view of customer purchasing behaviors and preferences. Now, second, that is a problem data warehouses have solved, but their current data warehouse doesn't have the usability or performance necessary for the type of real-time and relatively sophisticated analytics they're looking to conduct. So the data science team advocates migrating to BigQuery, which kicks off their journey of moving to a cloud data warehouse. Using Confluent and our library of pre-built source and sync connectors, we can build and scale real-time, multi-cloud, and hybrid data pipelines that move data from any source environment to the cloud data warehouse of your choice. Let's go through an overview of our implementation steps. Number one, we'll set up a self-managed Confluent platform cluster on an on-prem Kubernetes environment. Two, we'll extract customer data from Oracle to Confluent Platform using the Oracle CDC Source Premium connector. In this demo, we're choosing to start with an on-prem environment running in Kubernetes to match the environment of our Oracle database, which we already said was on-prem. But you can also choose to connect your Oracle database directly to Confluent Cloud through that same CDC connector if you'd like. Third, we'll stream the customer data from our self-managed Confluent Platform cluster in Kubernetes to our fully managed Confluent Cloud cluster with cluster linking. That's another good reason why we did CDC to an on-prem Confluent installation, so we can show cluster linking, which is incredibly cool and very useful in this common scenario that we're illustrating. Fourth, we'll extract order data from our second data source that's already in the cloud. That's that Postgres cloud instance with the fully managed Postgres source connector, putting that data into Confluent Cloud. 5. Once all of our data is in Confluent Cloud, we'll merge and transform the data sources with ksqlDB, generating a unified 360-degree view of the customer like we've always wanted. Note that for basic transformations like filtering or masking or things like that, some of that can be done in Kafka Connect using a feature called single message transforms, or sometimes called SMTs, at the level of the source connector. Now that's some flexibility, convenience, potential cost savings. It's a fine thing to do. But for our purposes today, we're going to keep it all in ksqlDB because it is a more powerful and more generalizable tool, and I think it makes for a cooler demo. Honestly, it is a lot more flexible, and you will end up using it a lot more. Finally, we'll load the cleaned and merged data into BigQuery using the fully managed BigQuery sync connector, where the data science team can do their thing, like creating real-time promotional recommendations. We're going to do all of that with some sample customer and order data. At the end of this session, we'll have run through everything you'll need to be prepared for your data warehouse modernization journey. And with that, let's look at this step by step. For the demo, we'll be deploying Confluent for Kubernetes, which automates deployments of Confluent Platform and makes it easy to configure all the components of our self-managed offering with a declarative API-driven experience that gives you kind of cloud-like elasticity, but in your on-prem environment. To set up Confluent for Kubernetes, make sure you have kubectl and Helm 3 installed. Create a namespace to host your pods and then set it as your default namespace. Install Confluent Operator using Helm. Here you can see that we've enabled cluster linking as a part of our deployment. Next, we'll install the platform components using kubectl. Of course, it'll take a moment for all our pods to deploy and run, but using movie magic, we can speed that up. Once all the platform components are installed, let's head over to Confluent Hub to search for our Oracle CDC Source Premium connector. This is a self-managed connector, so we need to download it and bake it into the Docker image so that we can find it later in Control Center, so it'll be class loadable by Kafka Connect when it runs. So we'll run the Confluent Hub install for the Oracle CDC connector. Next, let's take a look at the customer data we have in the Oracle database. In the customer table, we have fields like customer ID, customer name, and some other customer information. We're going to be using the customer ID field later to match our customer data to that customer's orders. In the Confluent Control Center, we can see the Confluent Platform cluster that we just deployed through Kubernetes and the Oracle CDC Source Premium connector. We'll supply all the necessary settings to access our Oracle database. This connector allows you to pretty reliably and cost-effectively implement continuous real-time syncs by offloading that data, getting that data out of the Oracle database and into Kafka topics. Once you've created the connector, check to make sure the connector is running. Always a good idea. Now let's check this new topic. It's oracle.admin.customer, created by the connector to see the records coming from Oracle. With our pre-built connector, you've now performed a highly complex integration that would otherwise take more than a few engineering months to replicate in-house. Trust me, this is trickier than it sounds. It's great to have connectors. Next, we'll bridge our two environments from our self-managed cluster with Oracle data to a fully managed cluster on Confluent Cloud using cluster linking. Let's start by provisioning our Confluent Cloud cluster. Select a cluster type and begin configuration. Select cloud provider, pick a region, availability zone, and launch the cluster. To enable cluster linking and mirror the on-prem Confluent Platform cluster to the new Confluent Cloud cluster we've just created, make sure your destination Confluent Cloud cluster has cluster linking enabled. Using the cCloud CLI, we'll create a destination-based cluster link. Then we'll create a mirror topic on the destination cluster and associate it with the cluster link. Let's go into the Confluent Cloud UI now, and you can see that the Oracle Admin Customers topic exists in our Confluent Cloud cluster as a result of that cluster link. Pretty cool stuff. Now let's switch gears and examine our second data source, which is orders data in Postgres in that cloud instance of Postgres. Let's take a look at the orders table. It has fields like customer ID, product name, order date, and cost. We'll need to get this data into Confluent Cloud as well, which we'll do using the fully managed Postgres source connector. Unlike that self-managed Oracle connector we used earlier in Kubernetes, this fully managed Postgres connector in Confluent Cloud abstracts away all of the operational burden so that we can get started quickly with just a little bit of data entered and literally just a few clicks. We'll tell the connector all about our Postgres database, launch it, and validate that it has created a new topic. And that's a happy thing. Now that our connector is up and running, let's quickly take a look at the topic it created, which is Postgres_orders, and check out the events that are there. Looks like they're there. Once all of our data is in Confluent Cloud, it's time to merge and transform it using ksqlDB, which lets us do real-time stream processing with SQL. Let's create a new ksqlDB application, that's the place where our queries live, and write some queries. First, we'll create a stream of customer data from the customer topic. And a stream from the orders topic. Then we'll merge the two streams on the common customer ID field. Next, we'll begin cleaning the data. We'll want to clean the data here in Confluent because the clean data can then be used by multiple downstream applications and systems without needing to re-clean it and reprocess it over and over again. So let's start by scrubbing the customer data from Oracle. We'll need to create a table from that stream. That's what customer data is. Customers are things, so they go in a table. But we may not want to provide certain sensitive data on a customer to the data science team. So let's remove fields like preferred credit card number. I mean, hopefully that was encrypted anyway, but we just won't even include it. Next, we'll want to create a table that aggregates certain metrics from the order data in Postgres. The data science team often wants to see variables like total number of orders, total lifetime spend for each customer. So why not just aggregate that in real time? We'll aggregate the count of order ID and the sum of order amount by customer ID to create those two new fields. We'll also want to know when the customer's most recent order was. So let's create another new field called last order with the most recent order date. With the data cleaned, let's join the customer and order data from the two data sources using the common field customer ID so that we can get a unified view of our customers. We don't need to load customers who haven't made a purchase in the past 5 years or longer into our new cloud data warehouse. I think that seems fair. So we'll filter for those customers based on the last order field and save on storage costs with the data warehouse. Now that we have our cleaned, unified view of the customer, let's load this into BigQuery using Confluent's fully managed BigQuery sync connector. Similar to the Postgres connector we used earlier, it's a quick and simple process to launch a fully managed connector. Let's tell the connector all about our BigQuery data warehouse, our GCP credentials file, the project ID, the dataset, desired DDL support options, and launch the connector. With that connector fully provisioned, let's go over to BigQuery and see what happened. We can see that all the data is here. We won't go through all the details, but it's sufficient to say that we've taken our data from our legacy database, bridged it from on-prem to a cloud environment, and joined it with other valuable data and processed it with ksqlDB. Then flowed it down to BigQuery, where the data science team would be able to accomplish and conduct their growing analytics operations. Okay, now you have a roadmap for how to modernize your data warehouse by bridging your on-prem environment to your cloud environment with Confluent. The good news is you don't have to use the same data sources and sinks that we used in this demo. Well, they were cool and all, but at the time of this recording, we have more than 120 pre-built source and sink connectors to meet you wherever your data and application needs are to help you get to production quickly and safely without building a lot of undifferentiated data integration code. Hey, thanks for watching this demo. We hope you found it helpful in thinking through how you can modernize your data warehouse with Confluent. If you'd like to learn more about how to build with Confluent and Kafka, and I hope you do, be sure to check out our recently launched Confluent developer site. That's developer.confluent.io, where you can access tons of free courses on Kafka, Connect, ksqlDB, run executable demos, read a patterns library, in-depth articles, get an index of podcasts, find out where meetups are, everything you need to know. And when you're ready to get started free with Confluent Cloud, we've got lots of free trial credits ready to get you going. Happy streaming.